Hello everyone. I'm here for our discussion topic number one for our system theory class. I would like to start off with my brief introduction. My name is Ram Karki, and currently I'm doing my master's degree in system and engineering management here at Texas Tech University. Also, I'm working as a senior system engineer for a HVAC company called Johnson Controls. I've been with the company for about 4 years now. Right after graduation uh, in 2021, I started working with this company, and I'm really loving it so far. Talking about my interest, I'm a very outgoing person. I think I like to go out, explore, meet new people, hang around with my friends and family. Besides that, I do practice a lot of sports like soccer, cricket, volleyball, and my career interest would be working on the building decarbonization. And also I'm very fascinated about the mission critical data center infrastructure, and how the HVAC company can play a role to shape the new AI and machine learning technology in this new environment, right? So, talking about the system I interact daily, obviously at my work, I do work closely with the water cooled chillers. So we do design, test, validate, launch, and optimize such kind of uh, mechanical water cooled chillers that are capable of cooling the massive buildings, hospitals, universities, stadiums, and also recently all the booming data center infrastructures. So uh, I consider our system as a open loop system. I'm gonna tell you the reasons behind that. So chiller system is a integrated complex system that has multiple, like lot of parts and lot of components. Those are assembled together to ensure it's a in a holistic view, it's a big complex machine, right? And it extends directly with the environment. It has like the core components like the input, output, stock, flows, and the behavior over time. So which I'm going to talk later in this video. uh, I consider this system as an open system because um, there is a direct interaction with the environment as the cooling tower are set up on the top of the buildings. The hot water coming out of the condenser loop would be evaporated out of the cooling towers and sitting on the top of the building. So it is directly interacting with the um, environment. On the top of that, it has all the various major components like input, uh, output, stock, flow, and behavior over time. For input, the energy and power drawn from the facility to run the major components like VST, motor, compressors, and various pumps for making the refrigeration cycle. As an output, we can look output as the cooled water loop that is capable of cooling the buildings, heat rejection from the cooling tower. Those are the output for our system, right? And for the stock would be the thermal energy that is within the system. Thermal energy in terms of heat, entropy, and enthalpy within the system, right? Those are the stock. Whereas the flow, for the flows, I would definitely consider the flow of the water going through the evap and condenser loop, which we calculate in terms of GPM. That's the flow within the system. And there's also the flow for the refrigerant, flow for the oil if it is a oiled machine, and behavior over time is calculated with various uh, things like how it performed in years to come, which is directly impacted by the foulings on the tube. Yeah, the efficiency of the machine will be degraded over time because of the various leaks, degradations of the component like the gaskets and rusty shells and all that. So those are the things that I think uh, makes this chiller system as a uh, in a holistic view. These are all the components that goes together to ensure the effective cooling of the buildings. And this is a very interesting system to me. So these are some of the topic I wanted to bring up on this first discussion. Thank you.